This video will explain how to create the sketch for question 4 in the Minds On. In order to create the sketch, we need to be familiar with the 5 key points for sine and the transformations that we will be applying to these 5 key points. The 5 key points for sine have 3 zeros. We have a 0 at the beginning of the cycle, and at the end, 360 degrees, and halfway through the cycle at 180 degrees. The maximum occurs halfway between the beginning and halfway point of the cycle at 90 degrees. The minimum occurs halfway between the halfway point of the cycle and the end of the cycle at 270 degrees. We want to remember this general pattern for the sine wave. Let's apply the first transformation. The amplitude is a half. This means that the maximum and the minimum must now be at 1/2. The zeros will be unaffected by the change in amplitude. I have a maximum at 1/2 and our minimum at -1/2. What I have right now, if I connected the 5 key points, would be a graph of 1/2 sine x. Next, the period. The period is 720 degrees. This means that I should see one cycle occurring from 0 degrees to 720 degrees. I should only see half a cycle occurring from 0 to 360 then. So, the beginning of our cycle will remain where it is at 0, 0. The end of our cycle, which is at 360, will occur out of view at 720 degrees. The halfway point of our cycle, which is this 0 at 180 degrees, will now occur halfway through the changed period from 0 to 720. The halfway point of that is 360. So we will put our new 0 at 360. This is where this 0 has moved. That is now there. Now, our maximum and minimum values. Our maximum and minimum always occur halfway between the zeros. Our maximum occurs between the beginning of the cycle and the halfway point. So, since our period has now been stretched out, it must occur between the beginning, which is still at 0, but the new halfway point at 360. So our maximum must occur at 180. And so I am moving the maximum there. This has been moved there. The minimum, which is at 270, will also move, but it will move out of the viewing window. So if I connected the points right now, I would go up to the maximum at 180, 1/2, and down to this first 0. The remainder of the cycle would go from 360 to 720. Next, I will apply the phase shift and vertical translations. I want to move each of these 3 points, so my beginning, my halfway point at 360, and this maximum, I want to move them 90 degrees to the left and 2 units up. Note that the scale on my x-axis is 1 square represents 30 degrees. So 90 degrees will be 3 squares. So I want to move 3 squares to the left and 2 units up. Let's start with the beginning of the cycle. 3 squares to the left represent the 90 degrees, and 2 units up. There's the new beginning of my cycle. So that point has been transformed there. Now, let's do this halfway point. 3 squares to the left and 2 units up. This maximum, which is occurring halfway between the beginning and the halfway point, will go 3 squares to the left. Again, that represents 90 degrees, and 2 squares up. 1, 2, and there we have it. I now have transformed this half of a wave, 3 units to the left and 2 units up. 90 degrees to the left and 2 units up. I now want to complete the rest of my graph from negative 360 to positive 360. First of all, I'll connect these points. There we have it. Now I know that the graph will continue down toward that minimum again, which is out of view, and then end up back at the end of the cycle, 720 degrees from the beginning. So I'm going to continue going down, and then to the left I want to complete my cycle as well. Now to the left of this point here, which represents the beginning of this first cycle, that goes up to that max of, and then down to that halfway point, and then continues off until out of view to complete that cycle. This must come down and then go back up. Now it goes down to the minimum, which is again half, and it is 180 degrees from this point. So I want to make sure that I go 180 degrees to the left. So each box represents 30. So that'll be 6 boxes, and right there would be where the minimum is occurring. So I'll continue the graph to that min, and then up out of view to get a look at the remainder of the cycle. So what I have, this portion of the graph represents this part of my sine function. This was the transformation that occurred to it, and it created this transformed function. And then I've created the remainder of the graph for the graphing window from negative 360 to positive 360 degrees.